Hello. For our group project, we decided to visualize data from two different sources, both the CDC and Google Flu Trends. So let's look at Google Flu Trends. While it provides a visualization built in, we also wanted to be able to look at the data in the raw format. So we'll select North Carolina, and then we'll click Download Data. What we see here is a Commodore Limited version of all of the data Google Trends has for the flu. So then we're going to import it into our software so that we can run some analysis on that and do some plotting. So we're going to also pull the flu data from the CDC. So CDC flu data, and we'll look at the weekly report. From this page, they offer their data in a raw format over here on the left side, United States surveillance data, 97 through 2006. So we'll click on that. And this is the one we want. I've actually already downloaded it here. So this is the data. It shows total number and week. So I needed to convert that just a little bit so that it looks like the same shape of the Google Flu Trends data. So I just did a conversion of week number to date, and then total count of cases reported. So now we're going to open the R console. R is open source, freely available, so feel free to download it and play around with it. What we're going to do is just some simple commands to just kind of go over some of the things you can do with that, and then we'll move along to what we actually did. So you get a lot of easy statistical and plotting things built in with R. So let's do test set 1, and we'll assign to it a sequence. C lets you define a sequence, so we'll do 1, 2, 3, 4, 5, 6, 7, just a simple set. And then we'll do T2, will be something similar. We'll go larger, we'll go 10, 11, 12, 13, 14. And then so we can see T1 has those items assigned, T2 has what we assigned to it there. So from here, we will, we can just look at the correlation between the two. So there's a built-in function core, T1, T2. Let's see, we have an incompatible number of dimensions. So we say 1, 2, 3, 4, 7, 3, 4, we only have 5 there. So let's adjust T2, or actually reassign to it. And we'll do something sort of similar initially, and then we'll change it. So 1, 2, we'll jump to 6, 7, 8, 9, 10. So that's 1, 2, 3, 4, 5, 6, 7 items. So that should be the same number of dimensions. We'll try our correlation function again, T1, T2. And we see we have a 0.96 correlation. And if we look at it in the reverse order, we should see the exact same correlation. I just did this as kind of a sanity check, and we get the same correlation. However, if we have T3, which has just one item correlating, we could do 1, 56, 56, 56, 56, 56. It's 1, 2, 3, 4, 6, 7. Okay, so we also have 7 items there. Verify that that's that. So correlation there would be T1 to T3. We should get lower correlation, and we do, 0.61. We can also very easily plot the data. So we would do plot, say, T1 as the x-coordinate, T2 as the y-coordinate, and we see the graph here. Just very simple example, but you can see kind of what's going on. T3 had the single item with a value of 1, and then 56 for all the other entries. So we see it comes through at 1 and 56, and we get an auto-scaling for our x-axis and our y-axis. You can also just get a quick summary, some interesting statistical information on your data. Summary, I can spell summary, right? There we go. Summary of T1, it gives you the minimum, the maximum, the median, some basic information. So now let's actually do something useful, and we'll read in the data we brought in from the CDC. So I already have that command in here. Basically, we're just creating a variable CDC. Into it, we're placing read. We're using read.csv, just a CSV file reader. We define the file as, this is where I save the file to, the one I modified with the date and the number of occurrences to. I'm telling it that the headers are not available in the file, and our separator is a comma. So all I have to do is this, and then I can look at CDC. This is the data. I could do a summary of CDC as well. And this is less useful just in the plain summary mode. So we'll also want to load in the data from Google Trends. So similar operation with Google Trends. We'll input the create a variable, and we'll read. So we're creating GT2. From that, we're going to read CSV, and file equals the file name. From here, we've got our working directory. And the file name, Google Flu that I pulled down earlier. And then our separator is the comma. And if we look at the data, we see all of the data. It's actually quite a larger data set. We could look at specific columns, so date. We would see all the dates there available. And here, this is how we would plot the data from this data set. We're going to grab just the data for the North Carolina column. We're going to plot as the x for the y-axis. For the x-axis, we're going to plot the date column. And for this to work properly, we just have to cast the date as a date type. In other words, enable to get the range defined as we expect. D range is a range that I've defined to match the range from the CDC data set, 2009 to 2010 flu season. So I've just already defined that in a range here. And just labeling the axes, and we can see what that's going to look like. So we see kind of a spike here, February, March time period. I'm sorry, this is the end of 2009, so this would be kind of September when you would typically see the flu spike. And we'll also, and this is useful in and of itself, however, we want to look at the correlation with the CDC data as well. So we'll add the CDC data to this grid. And in order to keep it from creating a new chart without and changing our scales and whatnot, we use this command, parameter new equals t. We want to, again, we're going to replot the Google Trends data. And we're going to tell it we want to not overwrite the chart to add the next data set to the current chart. And then we're going to plot the CDC data on top. Now you'll notice it messes up the axes here. I haven't had a chance to figure out why it does that, but they are the same axes. And we'll see, so now we see the Google Flu Trends and with circles, and the CDC data with these bars. So we see a bit of more of a spike with the CDC data here, but generally over the year it kind of follows each other, and we see a strong correlation between the two. So we've indicated a strong correlation between what users type in for search data that Google has been tracking and what the CDC has actually recorded in their laboratories.